Okay, so welcome to Math 2526. Okay, so last class so far actually we finished this topic estimation. Right, so estimation is we we want to estimate the population's information from samples information. So the story is just like that. So here we have a population. So for population, we have population's average for all people, and we have the sigma, the varying standard deviation. So those things we don't know. So how can we estimate this? So we say we just take samples of, okay. So from sample, we can find samples average and samples standard deviation is. So use those, we can estimate the population's mu and population's sigma. So typically we focus on population's mu. Okay. So so a typical situation is population's proportion. So if a population is 1-0 population, like here's 1-0 population, then we just focus on the percentage for say yes, like proportion. Okay. So here we have this formula with x bar plus minus z star times sigma over a. So this formula is we assume we know sigma. But we say in real situation, sigma we don't know. So if we don't know, so then we replace sigma by s, by sample standard deviation. Then we need changing this z star to t star. Right? So we have t table, t distribution. So we need to find this t star from t table. Right? Okay, so we also say if sample size quite big, then C table, T table, no much difference. So in typical situation, we can regard it for proportion. We still can use this star. And this for this proportion of this 1-0 distribution, we say this sigma equal PQ, or square root of PQ, and we can use A samples standard deviation thus. So here we replace this sigma by this s, but you still can use this star, right? Okay, so those are estimation problem. Okay, so typically how can we find this samples standard deviation? So we have a formula for find samples variance. Sample variance. Use this formula to find the samples variance. Then sample standard deviation, just take a square root. Right? So this is samples standard deviation. Samples standard deviation here. Okay. So here we say y divided by n minus 1, because this n minus 1 is degree of freedom. Degree of freedom for those numbers, like xi minus x bar. Degree of freedom for those numbers. Okay. Okay. So we say, so this is one purpose from sample. From sample, we can from samples information to estimate populations information, right? From sample to population. Okay. So why we need to take a sample? So this is for our purpose. We need like sometime we want to estimate this, or sometime we want to check people's claim. Okay, so let's say like this mu we don't know, mu or sigma we don't know. Right, but some people claim they know this. Let's say mu will be this number, right? Mu will be equal mu 0. So the mu 0 can be the mu. So we want to test their claim. Is their claim true or not true? So this actually is another motivation for statistics. We wanted to check people's claim. Okay. For example, people always say my product is very good. Like for some salesmen, they will say the quality for our product is very good. Right? So we wanted to check their claim. Like we wanted to check the quality of the product. So this means that we want to check their claim. They always say their product quality is good, but we wanted to check, right? Okay, so we say those is quite a common story in our daily life. Some people say something, so before we can believe them, we want to have a check, right? Okay, so for example, let's say the president of this school claims that the 15% of students can get a scholarship. Okay, so we believe him. Oh, so we need to test this, right? So we do a survey. We check suppose check 100 students. So among these 100 students, we find only 12 students got a scholarship. So this means from our sample, this percentage is only 12%, right? But their claim is 15%. So we have evidence. It seems like their claim is not so true. But we need to test this. We want to make it, when we make a decision, we need some good reason, right? So the question, can we reject the claim, or can we should accept the claim? Okay, so this is like a first example. And so we have many of those kind of examples, right? So let's check this one. So the president of the school claims the average GPA for all students is 3.0 and with standard deviations. So this president claims the mu is 3.0 and sigma equal 0.3. So this is his claim. He claims he knows us. Okay, so to test his claims, so I check our class. I found in our class we have 25 students, and I find our class average is this 2.95. So their claim is 3.0, but we find the 2.95. So they have some difference, right? So in our class is not 3.0, it's less than 3.0, right? So the question says, can we reject this claim with with some confidence, like with confidence 90%? Or can we say I have 90% confidence to say the claim is not true? So we want to answer those kind of questions. Okay. So this is actually the common story. This example one. Let's see. Maybe like so here 2. You can say 2.95 and 3.0 is quite close. Yeah. So now let's check this. Like this is I'm changing this like maybe so if let's say their claim 3.0. Okay. So maybe if our class 2.95, so we can say, oh, this difference is not so big. So how about the here, 2.85? Then we can say, oh, maybe like this difference is huge. So here, the question actually is just to check these two numbers close or not so close, right? Okay, so those kind of questions are we say the hypothesis testing question. So today's topic is hypothesis testing. Okay, hypothesis testing. Just test. So we regard their claim as their assumption or hypothesis. So we want to test their hypothesis or their assumption or their claim. Okay? Okay. So we say we have many of those kinds of problems. So how can we test this? So basic idea is our sample mean and the population's mean, or sample's average and the population's average should be close. So this is the basic idea, right? So if they are not so close, then let's say, like suppose some people say mu is here. So and our x bar is here. Then we can say, oh, this mu equal here maybe is true. But if x bar is here, then we can say, oh, their difference, their distance or difference is too huge. So if x bar is here, we believe populations means also in this part, in here, right? So here we say there's x bar, so we know this x bar will follow this normal distribution, right? Mu sigma over radical A. Yeah. So this story is just like that. So x bar is here, maybe the true mu can be here. So this one can be true mu, right? So if x bar is here, true mu should be in this range. Okay, so x bar here, true mu should be in this range. So then if you say this one, so we say, oh, this distance is too far away. Okay, so we say the basic idea is very simple. So x bar and mu should be close, right? So the question now is how to judge these two numbers are close or not. How can we judge them? Now, for example, we have these numbers like x1, x2. Their distance is 4. So can we say, like, okay, so x1 here, x2 here, let's say x1, x2, their distance is 4. So can we say these two numbers are close or not so close? So actually we cannot see that. Now we cannot judge it from only judge from that difference, right? So for example, let's say suppose we're talking about annual salary. So I say my annual salary is this, and your annual salary is this, and our difference is $2,000. Okay, so now let's talking about hourly wage. So I say my wage is this 15. I work in a store and my hourly wage is $15 and 15.5, and yours is $20, right? And the difference is $5.10. So we believe this is difference huge, right? This difference not so huge, small. So we really cannot judge this number is big number, small number only from the number. We should judge this based on the situation, right? Okay. So we say how to judge these two numbers, close or not so close. Actually, it's not so straightforward, right? Okay. So here, how can we judge? Those two numbers are small or not so small? So in statistics, we introduce this notation. We introduce this important notation. We say p-value. Okay. So this notation is very important in statistics. We just use this number to judge the difference big or small. Okay, so what is p-value? What is p-value? So we just make things like standardized. We just check standard normal, like general normal, we will convert to standard normal. So suppose this is standard normal, and here is 0, right? Okay, so if this number is here, we can say, oh, difference with 0. So this number with 0, let's say we have this number 0. So this number and 0 close or not so close. So like this number here with 0 close or not so close. So we introduce this p-value. We regard the cutoff point, and this probability is p-value. So if the cutoff point, this point number is here, let's say this z here, so there's p-value. And if z is on the right side, the cutoff point here, then there's p-value. So we call this as one tail. We just check one side, right? One tail. Okay. So sometimes we need to check both sides, like suppose the cutoff point here. So we need to check this side, this side. So there's p-value. So we use the p-value. We need to count both sides. So p-value this part also include this part p-value. So we call this as the two tail. Or two tails. So we have one tail, two tail. So when we need, so when we use p-value, there's one tail or two tail. This depends on situations, right? So we have one tail test or two tail test. Okay. So now, how can we? So at the first we say for general normal, we wanted to convert standard normal. So from standard normal, we can let's say so find the p-value. So let's say this is standard normal, not standard normal z, right? So if we know that sigma and some people claim mu equal mu 0, and suppose like some people claim there are no mu and no sigma, or sigma equals this number, then we can find this cutoff point we call z value. Like so we know x bar, right? We take a sample, we have x bar, and mu we know equal mu 0, and sigma equals that sigma, right? So we can find this number. So this is cutoff point. So because this cutoff point, we need to check from this cutoff point is from z table, right? So we call like okay. So you can see here 0, so you can find this cutoff point. So we call this z value. So then p value is this part. Okay. So if we don't know sigma, then we just replace sigma by s. So then such number, this is cutoff point, right? Just a cutoff point. But in this case, we need, let's say, we need to check a t table. So cutoff point here. Then this is just p-value, or if cutoff point here, then p-value is this. So this is the t-value. So z-value, t-value means we need to check. Once we have this cutoff point, so we need to. So here we need to check a z table. Here we need to check a t table. Okay. So we call those cutoff point as test statistic. So we use those numbers to do our test. Okay. So by the way, statistic means any numbers from we can calculate from sample, from data. Okay. So maybe so here we mention this again. Statistic. So statistics, we just refer, so have two meanings. One is the name for this course, statistics. The other is statistic or statistics, any number. Numbers, we can say those numbers can calculate from, we can get it from data. So data is just a sample, right? So we can say from data. Okay, so p-value is just like that, like if cutoff point here, so this is p-value, or sometimes this is p-value, and this is sent 0, right? Okay. So if the p-value very small, then we can reject. We can believe those difference is huge, right? P-value is small. If p-value is small, means the difference is big, right? So maybe we can reject the claim. Okay. So how can we judge? Also, we can say p-value small. So how can we judge this small or big? We need to compare this we're giving number alpha. So this number is called significance level. Okay, significance level. So use this alpha. So we can compare it with p-value less than alpha. So we can say this p-value small p-values. Small means their difference is big, right? So use this, we can make the decision. Okay. So here, for those kind of problem, we usually will set their claim as like as HO or HA. So here their claim is true or not true. So we put this as there's claim or over claim, right? Maybe we say this product is good, and we say so your product not so good. So like we put this as two hypotheses and two arguments. So we wanted to determine which one is more likely to be true, right? Okay. So let's say here HO as here's for hypothesis HA. So HO, we call this as a non-hypothesis. So this non means not none, like or no difference, like no difference or no difference. Okay, so usually like this, like some people say mu equal this number, like mu equal this number. So, or we can say like mu and mu zero, no difference. So this HA means we say A means alternative hypothesis. So this HA can be let's say mu equal this number. We just don't believe them. Maybe mu larger than this, right? Or maybe mu less than this number, or mu not equal this number. So here HA is over assumption. So here over assumption usually like HA, some people say good, we say maybe not so good, right? So how can we determine good and not good? So sometimes mu larger than is good, or less than is larger than is not so good, or less than is not so good, or not equal is not so good, right? So those like not good. So we have three options. So which option we should use depends on situation, what the good meanings. Okay. So now let's check this or example. Okay. So some people say mu is 3.0 with standard deviation. So here we focus on, we'll just focus on mu. So some people say mu HO is this, mu equal. So equals 3.0. So here we put 3.00. So this doesn't matter, right? So what is the HA? I'm sorry. Oh, this should be HA. Yeah, I made a mistake. Okay. HA. So HA is like a good or not a good. Like if some people say good, we will check. We will say maybe not so good, right? So what good meanings? So here we're talking about GPA. So meaning GPA is, so like some people say GPA should be here. So we know GPA good means high is good, right? So not good is less than is not so good, right? So here we use this mu less than 3. Some people say mu is here, so we say mu maybe should be here, less than. So less than not good, right? So HA we use this mu less than. Okay. Okay. So then we just find the test statistics. So here, because we know sigma, so this number x bar minus mu 0 over sigma radical a. So this is z value, right? So x bar is the overclass average. So we find overclass average is only 2.85. Like stored just like that. Some people say average for all people is 3.0. But in overclass, overclass average is thus 2.85, right? So we want to check their difference is big or close. So at the first we find this z value cut point negative 2.5. Seeing this p value, so here we have cut point, right? So here's 0. Our cut point negative 2.5. So their distance big, not so big. So we need to find this probability. So there's a probability p value. Okay, so we find, so check the table. We find this p value is thus 0.006. So this p value is small or not so small? So we want to determine this number, small number, big number. So we say we cannot judge it only from this number itself. We need to compare with other number. So other number is, we say from here. Can we reject the claim with confidence 90%? So if it is 90%, then this alpha is 10%. So we can say actually like 90% confidence to say make some conclusion with 90% that our conclusion is correct. So this means also 10% maybe our conclusion is wrong, right? So this alpha is, we also can understand this alpha is the percentage that our conclusion may be wrong. So this alpha is 10%. So this number is very, very small compared to 10%. This number very, very small. So we can say, okay, so their difference is huge. So we can reject, if they are huge, so we can reject their claim. The true, the average, say 3.00, so we say cannot be so high. Should be like less than, so at least should be less than 3.00, right? Even though we don't know the true percentage, true mean average for all, but so even though we don't know where the mu is, but we can say mu cannot be the 3, should be less than 3, right? Because our sample mean is here, so we believe population's mean should be in this range, right? Okay, so we say So okay, so then make our conclusion. So we can reject the claim. So we can say, so we can say, can we reject the claim? We say yes, we can reject the claim. We believe the average GPA for all students cannot be so high. Okay. Okay. So we say so here for such problems, for hypothesis testing problem, usually we have 4 steps. First one is the hypothesis. Now, second one is calculate the test statistic. Then find the p-value. Then make a decision. Okay. So let's check another example. So this example the same as the previous one. The only difference is the claim, the pattern of the score, the claim is only about mu. The claim average GPA for all students is thus. So they do not claim the sigma, right? So sigma, so here we don't know. Okay, they only claim this mu. So to check their claim, I check. So I regard our class sample. I check our class. We find our class. We have 25 students, and we find average in our class is thus. So we find in our class, so we regard our class as a sample. So sample means a sample size 25. Sample mean is 2.85. And from our sample, we can find standard deviation, right? So there's a sample standard deviation. So this is sample standard deviation. So from our class, we find this, find that, find a sample, find our class mean and class standard deviation. So this is S. Okay. Okay. So the story is quite the same. They say average of all is here 3.0, but in this example, in this sample, we have only 2.85. So we want to determine this distance is big, is a huge distance, a huge difference, or quite small, no much difference, right? Okay, so we consider such a problem as a testing problem. So first one, so the hypothesis. So HO is equals as, and HA, so here HA, I'm sorry. HA is mu, so again less than, right? So here we're talking about good, so not so good, less than. So then we calculate the test statistic. So this time formula quite the same. X bar minus mu 0 over sigma. So here replace sigma by S, or S over radical A. So this number, we call it the t values. This means we need to check a t table. Okay. Okay, so the story is quite the same. Okay. Okay. So this is 0, and here we find our cutoff point negative 2.14. So this is p-value. Okay, p-value here. Okay, so we just want to find the p-value, make our decision. The p-value equals this probability. So this probability, we should check a t-table. Okay, so t-table, so this is t-distribution. The t-distribution of degree of freedom, right? So here, degree of freedom n minus 1, 24. Okay, so degree of freedom n minus 1, right? So now let's say, okay, so we want to find this probability. So degree of freedom equal 24. Cut point is negative 2.14. So from this table, we can find the probability. But from t-table, let's say t-table, we cannot find the probability. There's a t-table. So the t-table only give us some typical cutoff points, right? Like for so here, let's say for this t-table, the degree of freedom 24. So we just only have those cutoff points. Okay. So there's a typical cutoff points. So here we overcut the points negative 2.14. So negative 2.14, we just check positive, right? So this is same. So we say so negative 2.14, there's a probability, and thus positive 2.14 same, right? Negative 2.14. So here's 0. So here we do not have 2.14. Do not have this cutoff point. So we can only check its neighborhood. Okay, so we want to find this cutoff point 2.14. So from here 2.14 is here, right? Between, let's say, 2.064 and 2.492. So we cannot find the exact cutoff point. We can only find its neighborhood. Okay. So let's say, so what is those cutoff point meanings? This cutoff point meanings, let's say, here go up. Okay, let's say this cutoff point meanings. Okay, so so what is the two column meanings? Cutoff point. Okay, so this meanings, this is one tail is this, and one tail is 0, 0, 1. So this is those cutoff points, the one tail 0, 0, 2, 5 and 0, 0, 1. So our p-value is just between them. Okay, so we can say that our p-value is this probability, right? This or this same. So one tail cutoff point 2.14. So we know this probability is, so we just check one tail, so between these two numbers. So we can say we cannot find the exact p-value. What we can say is only we know p-values between these two numbers. So less than bigger one, larger than smaller one. So this is only we can get from the t-table. Okay? But this is not enough. We can make our decision. So we say p-value. So actually let's say, to make our decision, we just need to compare p-value with this. So this p-value is between 0.025 to 0.001. Okay, so we can say this p-value will less than this, right? So our decision is this decision this distance is so we can believe this distance or the difference is quite big, so we can reject their claim. So p-value less than alpha h a. So h is this. So we can say we will believe true average. Maybe like we cannot say true, right? We say average for all people or population's average cannot be so high. Should be less than 3.0. Okay. Okay. So actually, so here we say the only question we just judge there's two numbers difference big, not so big. So we can use p-value. We also can check because we just only compare the 10%, right? There's compare the alpha. So we can just find this cutoff point for 10%. So we call those as t critical value. Or we just say the c critical value or critical value or the t critical value. So we can see that there's a negative 2.14 so equal positive. Like we can have this. There's a 2.14. This number is a big number, a small number. This number, big number, small numbers. So how can we judge this? We need to find the critical value. So let's check the t-table. So this time degree of freedom 24. And we want to find, so we just want to find this 1 till 10%, right? 10%. Okay, so we find this 10%. 10% is this. So we say this is t critical value. So like this is 1.318. This is 10% cutoff point. And so let's say, so let's go back to here. We say to judge this number, the big number, small number, we just compare with this. We use this number to, like say, use this number to judge a given number, the big number, small number. Okay, so if number here, we say, oh, there's small number. If number here, there's a big number. So 2.14 is we can say 2.14, there's a big number. Okay, all right. So this big number means the difference is big. Okay, so if the difference is big, so we can support this and reject their claim. Okay. Okay, so this is a typical example for hypothesis testing problem. So testing problem is just to judge whether the difference is big and not so big, right? Okay. So here we have little bit confusing things that we sometimes we need to check T table, sometimes C table. So we say this is the story is if sample size small, we should use T table, T value, right? Or if sigma we don't know, use T table, right? So if sigma is no, then C table. So other things is if sample size quite big, we always can use Z table. So typical situations like proportion, let's say percentage. So here, let's check the example 1. Okay. So here, their claim percentage will be 15%. So we're talking about scholarship. So for us, we can regard our scholarship as high is good, right? So the president say our scores, the chance to get a scholarship is quite high. He wanted to use this information to attract more students, right? So we wanted to test this. So we find only over only 12%, right? So they say 15. So we find only 12%. So there's 3% difference. This difference is big difference or small difference. Okay. Okay, so we just change this. Why I always made mistake? Yeah, HA. Sorry. Okay. Yeah, HA is less than, right? So here we calculate first. The second step is calculate the test statistic. So this is just let's say there's the formula x bar minus mu 0 over sigma over radical n, right? So this is z value. So in here, x bar is p. Okay. Oh, I made a mistake here. This is p hat minus p0. Okay. Yeah. So just plug in here. So let's say. So p hat minus p0. Then sigma become radical p hat q hat over radical n. So how many students we checked? 100, right? So 100. So we just plug it in here. So that's equal p hat is 12, right? And p0 is 15. Okay. So here, this sigma, we don't know. We can use p hat q hat. Also, so what is p? So we can use the 12 p hat 12. So here there's a question. So we should we use this p hat q hat or pq? So this is a logic issue. Okay, so let's say that here, if some people claim this 15% for all, so this is let's say this 15% is for all population, right? So we believe, so here at the first we just believe them. So if we believe them, so we should use this. So they say they know there's p, right? So here we can use 15. We should use 15. So p, not p hat q, just pq. So q 85, right? So then divide by 100. Okay. So then here maybe need a little bit of calculation. So find this cutoff point. Okay. Let's see. Let's see. So here a little bit of calculation. Okay. 0.15 multiply. So divided by okay 0.035. Okay, so we find this equal negative 0.84. So this is z value. Then we can check a p-value. So this time, so this is z value. So we can find the exact p-value. So p-value okay 0. So negative 0.84. So this is p-value. So we know there's a p-value from the table. We can just check positive A4. Okay, so 1 minus, so check positive A4. Then we find there's a probability. Okay, so I leave this for you. So I check by myself. I say this p-value is quite big. So let's say decision. So alpha is 95%. Claim with 95% confidence. So this means alpha is 0.005. So in this case, the p-value will be larger than this alpha 0.005. So our conclusion is we cannot reject the claim. We cannot reject the claim even though we have some evidence. Right? They say 15%, but our survey from our sample is only 12%. So it seems this we have evidence to reject the claim. Right? The percentage cannot be so high. Like we have this evidence, but we say our evidence is not strong enough. We have to accept their claim. We just say accept their claim. Okay. Okay. So this is today's topic. So today's topic is hypothesis testing. Okay. So we just so hypothesis testing process is just at first set HO, HA. So HO, some people's claim. So usually HO we put this as equal. Non-hypothesis, no difference means HO is equal, and HA can be this, can be large, can be less than, right? So depends on what good or not good meanings. So then we calculate the cutoff point or test the statistic. So z value or t value. Then we determine p value is small or large, right? Then make our decision. Okay, so there's a topic for hypothesis testing. So hypothesis testing is a big issue in statistics. So maybe next class we will continue this topic. Okay, so we can stop here and see you next class. Okay, so thank you.